Words and introduction. Thank you very much for let me share my whole screen so we can have it. Thank you very much, all the people attending. Can you confirm that you see my screen, my whole? Yeah. Okay, so thank you very much, everybody, for being here in this webinar. So what I will try to do in this 40 minutes or so is to make a very brief presentation of what is EUCAIM, and more precisely the part that relates to the processing of data in the conditions of high level of monitoring and ensuring that the data cannot leave the secure environment. So basically, EUCAIM is a big project, very big project with 76 partners at this moment, but it will be more than 90 once that the new amendment is signed. That is aiming to have federated infrastructure for sharing data related with cancer imaging. So we have two models that have been defined, what we call the Atlas of Cancer Imaging, which is existing data that has been used, has been produced in research projects or clinical trials and on research infrastructure that are being made available, and a prospective system in order to collect data on demand for real-world data analysis and creating observational studies. So I will concentrate most on the right side in this webinar. So the first point that we did in the case of EUCAIM was to ensure that we have a common data model that can guarantee that the data, the different providers, is interoperable. And for this purpose, we have developed a hyper-ontology that is published on Zenodo and also available in this link. You will have the slides at the end of the presentation, I guess. And so in which you can go through all the different terms that we have defined and implementation that it's being performed for FHIR and OMOP to facilitate the integration of your data in the platform. So let's go to the architecture very briefly. So I'll try to dedicate most of the time to the demo. So but in order to understand well how the EUCAIM platform works, it's important to understand that we are working on a federated environment. We have a central hub that has the services that are needed to construct this federation, like a catalog that has the collection of data sets from all the different providers, a federated search which provides the discoverability of the data, a process for requesting access to negotiation, and a distributed processing that is on the making and being prototyped at the level of different providers at this moment. Then we have the data holders that have their own nodes that connect to this federation, and two special nodes that we call reference node that act as a catch-all that can host data from other parties and expose them in the platform. This is especially relevant for projects that don't have capability of keeping the data alive beyond the project. So we defined 3 levels of interoperability, and this is also very important because it defines more our philosophy. So the tier 1 interoperability defines the interoperability at the level of the catalog. It means that the metadata that we have from the different collections are compliant and to a specific schema. The tier 2 means that the data is discoverable, so we can search for data and you will see exactly what does it mean. And the third level is the processing of the data, which means that the data also has to fulfill our common data model. So in this federated model, we have components that are stored or are hosted and deployed at the central services, and components that have to be deployed at each provider site. So we have a catalog, and in order to connect to your local catalog, if you have one, we need a FTP, a Fair Data Point service that can be used to harvest the data from your local catalog. Then we need a query mediator to transform the queries from the federated search on the specific format of and the APIs that you have at your local site. We have explicit, implementation that can work for FHIR, for example, but we have also a procedure for developing additional components for your own model. In this case, you don't need to have fully the data available in this sense. We have the negotiator, and we have the distributed processing with a materialization company that transform the data to the specific model of the EUCAIM system. So what we will show here is this user journey that we have developed, which basically is first discovering the data that we have available with using our federated search and our catalog, then requesting access. That will be a short part in the presentation. And then after the request is completed, the request goes to an access committee, which has to approve the access and prepare the permits to allow the user to access explicitly this data in the platform. So that's the whole life cycle that we defined for the user. So that's also important to understand that this is a part of the system, and we also are supporting the capability of making the data sets publicly available, the metadata of the data sets publicly available on the scholarly repositories, so you can cite directly the data sets in your publication. So only the part that is related to the aggregated metadata, because the access to the data is only always by request, right? So we have defined this complete scenario. So then going to the SP, right? SP is a term that is being defined in several. It was defined in the Data Governance Act, but it's now very prominent in the European Health Data Space regulations. So in the Data Governance Act, it defines this SP as a physical or virtual environment an organization means to ensure the compliance with the union law, especially with respect to the data subject's rights. So it's an environment in which the intellectual property rights, the confidentiality, the integrity, the privacy are well respected according to the regulations. Being more precise, when the European Health Data Space, that as you probably know, the European Health Data Space is going to transform totally the way in which research in health is being conducted in Europe, with the obligation for the data providers, the data institutions, the health data institutions in Europe, to provide the data to the researchers based on specific conditions in secure processing environments, has defined more in detail this concept of SPE. However, it is not fully now defined in terms of the standards and specific measures, but it has several principles that you have to follow in order to be selected or registered as a SPE. So first is the restricted access to authorized participants. This is something that's very common in all the research infrastructure, to minimize the risk of the unauthorized reading, modification, or accessing. They limit the input to a specific person that have the permission to do it. They ensure that data users have only access to the specific data that is covered by the permit. To have a very detailed monitoring and logging of the actions performed by the users, and the compliance to other security measures. So we have implemented several components in EUCAIM and in Chameleon to address all these principles that are defined in the SPE definition, which basically we use life science AII for authenticating and providing the authorization entitlements to be used. We use access control lists and projects to isolate permissions and ensure that the access is restricted to a specific subset of data. We have specific roles to upload the data. And also we have an environment in which the data can be accessed, but not downloaded. In this way, the researchers can process the data in situ, but cannot get the data out. And we have a blockchain that logs the actions performed by the researchers with a specific granularity. So that was my brief presentation of how is the background. So I'll try to make a presentation in two parts. First is more the
data access part in which I will access the dashboard, I will explore the catalog, I will show information on which are the profiles that interact with the platform, show how to register briefly, and log in the platform, and make all the process of searching for data, requesting access, and completing the negotiation. The rationale is that I am a data scientist that is looking for pediatric data of magnetic resonance image. That will be the filtering criteria that I will use. Once that I have access to the data, I will go to my environment. I will access the data in this secure processing environment, explore it, and process it using a Jupyter notebook that we have prepared, in which you can see how they process the data interactively and also in batch mode, considering that you may run long-run jobs. So these are the links. We have prepared a demo, but we will do it live it should be performance. So let's start with the first part of the platform, right? So I'll go a little bigger, I think. No, that thing is okay. So this is the main page of the EUCAIM, the main dashboard. So if you don't, the easiest way is to go to cancerimage.eu, and then from cancer image, you can go to the dashboard, right? So that's the easy way. And you have several brief information about what are the profiles and what are the information in a brief aggregated manner. So we have a public catalog here, and we can go to our public catalog. The public catalog does not require authentication, so you can access freely as an anonymous user. So then getting there, I see that there are many connections. I can also say, let's see, by modality, if I have data from magnetic resonance, I see that there is data from magnetic resonance. I say, okay, it looks that this is irrelevant for me. I will try to go and access data there, right? So I will go to the dashboard then. The first step is I would like to become a user. So I go to become a user. I have all the documentation there. I have all the steps for here for requesting an account. We rely on LSAI, but we allow only users that belong to the EUCAIM group, EUCAIM virtual organization. And in this EUCAIM virtual organization, it's added by manually after revising the access. So I already have an account, so I will go to my profile, I will log in. I can use my own institutional credentials. Maybe this, no, okay, so I will go through LSAI using the UPV credentials, and now I'm getting back, once that all the process is completed, to the, I would say, private part, right? In the private part, two applications appears, federated query and negotiators. We have also help desk, thankfully provided by EGI in this case. So in the federated search is when I can go deeply and understand how many studies and how many cases do I have from a specific searching criteria, right? So if I go to search, what it does, the federated search, is to send a query to all the providers that I have in the federation. At this moment, we have 4 providers in the federations, distributed providers, which returned the number of subjects and studies that correspond to the filtering criteria. I didn't put any filtering criteria, so I have the whole list. So let me go first and say, okay, I'm looking for children. I'm looking for pediatric cancer images, and I'm looking also for magnetic resonance imaging. So I add the 2 criteria. These 2 criteria are coded in the standard terminology that the EUCAIM uses, and this is distributed to all the providers, which translate in this process the query to the individual's formats and return the aggregated view of the number of cases and the number of subjects that fulfill these criteria. As you see, the number
the numbers that appear are lower because these are the number of cases that fulfill this criteria. This is also very important because in this way, you know exactly if one of the data sets has, the exact number of cases that has each data set with respect to your criteria, right? So in this case, we realize that for the case of pediatric MRI imagings, I have 200 studies in this case of the pre-match neuroblastoma, right? So this is when all the process has been completed, right? Okay, so let's go to this. So if I click on the neuroblastoma, I go back to the catalog, and then I can get the details about this data set. So I can see that these data sets have different body parts. I have more information. I can see all the conditions of access, and I can decide that, yes, this is relevant for me. I will request access to it. So I will add it to my basket, right? And I would request access to it, right? So how does it work, the request? So the request is performed through a tool developed by Bimera Eric, which is the negotiator. Again, access to the data is performed under permission given by the access committee. So I will make a request. And this request, I have to give a title. I have to give my details. And I provide some information, like for example, the institutional letters, my consortium details, a cover letter, a hypothesis, the objectives, the materials, which basically, in this sense, reflects to the number of, the resources that you may consider. I will say on the GPU hours, the expected results, the timeline, which I can say that is June 25, December 26, the ethical approval, and if I have a project and other things, right? So I have to fulfill all the information like it were a project request. So I check it and I make a submission of the request. Then it gets in the process of being evaluated, right? So this is the view of the user, of the searcher. Let's consider that I am here. I have another window that is at the level of the evaluator, right? So if I refresh, I can see that this is the one that I have just requested, and I can approve it. Approve it doesn't mean that I have access. Approve that this means that it is eligible, but it will appear as in progress in the system, right? Okay, so that's the process. So normally it takes the time that the data set responsible has to check that the conditions are okay, and then the data set responsible will send you an agreement that you have to sign in order to access the data if the conditions are like this. Right? Okay, so let's assume that we have completed this, but to facilitate, I already have permission given to the same data set in another situation, right? So I have also prepared before. You can see that in my negotiation summary, I have 4 data sets approved and 3 data sets that are under evaluation, right? Neuroblastoma is the one that we have just requested, but I requested before, so I have access to it already, right? Okay, so I don't need to go back to the catalog. I don't need to go back to any place. I have the information of my approved data sets in this area that only appears when I log in the platform and I have process approved. Right, so I go back to the catalog, and then I see that there's a link that says Image Data Access URI. In this Image Data Access URI is when I will be able to access the data properly. Right, so I click it and I have left the central hub and I have moved to the one of the providers. In this case, the provider is Primage, and it's stored in one of our reference node, and this is the case of the UPV reference node. So I can have more details about the specific information that this dataset has in general, and I can log in. Let me see if I have already logged in. Maybe the credentials are. Let me check. Yeah, perfect. So sometimes get expired if you get a log. And then this is the next step. So I can see the history of the data set. It has been used by different times. And I can go and request access to it. For requesting access to it, I'll copy the ID and create a virtual research environment, a secure virtual research environment, because the only way to access the data is on a secure environment. So I will use on the apps, I will log in. I mean, we are trying to streamline all these login details. This will be, and I will create a session, an application. So we have a catalog of applications. So as you see, this is Kube Apps. Is our backend is a Kubernetes system, and I have a collection of different interactive applications that I can deploy on this Kubernetes for me, right? So I also have automatically a namespace created in this Kubernetes. So everything that I do is only in this namespace. I cannot access data, applications, or whatever that the other users are deploying on other different namespaces. So I will create a Jupyter PyTorch environment. I will say deploy. I will give some demo that already have it in my rehearsal, and I will copy the ID of the dataset that I want to access. If I will not have permission to the dataset, the operation will fail, right? So this is automatically checked by the platform, right? So I will deploy, and it will create the environment. I have to say that this is real time, and this is quick. This is quick because we are creating pods on top of a Kubernetes instance, so we don't need to boot the virtual machine. Everything is, and also the VMIs, not the VMIs, sorry, the Docker images or the container images that correspond to the different applications are preloaded on the platform. So this is quite quick. So it says that my application is ready, so I can go to this through a reverse proxy. That's the important thing to say. We, as I mentioned several times, I cannot access the platform. Sorry, I cannot download the data. I can only access the platform through a remote server, right? In this way, I click on this and I access to this environment, this desktop interface in which I can process the data, right? So first is check that the data is there. So I open and you can see that I have I have several folders automatically created. I have the datasets folder that has the different datasets. I have the persistent home in which I have the information that I have created for different virtual research environment. I can share it with different datasets if I have permission to several of them, and a shared folder to share information with other colleagues. In the datasets, you can see that we have all the individual folders, and in each folder, I have access to the DICOM files. These are DICOM files. Maybe if I put it on a view mode that is easier to see, these are DCM files, right? Another important thing is that we are not copying data. We are creating virtual views through using symbolic links on volumes that have permissions created for the user. So in this way, the interesting thing is that if I have 100 users accessing the same data in different data, even in different data sets, or the same data sets, I'm not creating a different folder for each view or each data set. I simply created a specific folder with symbolic links, so it reduces the footprint. Okay, so let's go and use Jupyter Notebook, in which I have prepared a simple notebook there. Again, Jupyter has to be run within the platform. I cannot run it outside because I will risk the privacy, because I will be exposed to the vulnerabilities that Jupyter may have in order, and other people could access to the data, right? In this way, whatever it is tried to be downloaded, it will be downloaded to this virtual environment, not to my local computer. I can upload data. I can upload my own program files, right? I can do it through the interface, but I cannot download anything. That's the way. When I complete all the research, I will request the downloading of the outputs, and this downloading will be examined by one of the person of the team before it being copied to a place in which the user can download. This is the way to ensure that the researchers are not trying to take some information out of the platform that he or she will not be authorized to, right? So in this persistent folder, I have one Jupyter notebook that has very simple things, but I think it's nice to show how it works, right? So yeah. So first is very simple, is to extract information about the paths where the data is stored, right? So it simply gets information about the paths, so I can use it to see, to start processing the data. Along with the images, you also have one important file. You have two important files that are called index.json and efforts.json that contains, index.json contains the list of studies and the specific paths to all the images or to all the studies that you have requested. This is important because we could provide you with a specific subset of the images that you want. Imagine that you would like to have MRI, and you have in the same data set MRI and CT. In this index.json, we can prepare the links to only the MRI images. So in this way, your models, can go through this list, and you will save time on identifying other data that is not useful for your or can perturb your model, right? Index.json has the list of all the elements, and eForms has the clinical data associated to the patients. So let's process the index.json. So this is very simply a snippet of code that tries to extract from this index.json the paths of the different files. And with the paths of the different files, I can, for example, print and display an image, right? And this is an image in the Jupyter notebook that corresponds to one of the studies. As you can see, this is extracted from pediatric cases, clearly. And also I can get the DICOM tags of the study of this specific image that you see that correspond to MRI image, and you have all additional details at the type of the vendor, you have protocol, you have body part, you have many other information that could be relevant, right? Then absolutely, all the information related to the subject, it has been anonymized, and information with respect to the provider is also pseudonymized. So, but let's go something deeper, right? So, you would like to process the data, and processing the data could take time. So as an example, we have prepared a very simple Python code that goes through all the different files and identify if the file is, the view of the file, if it is sagittal, transversal, or longitudinal. This is, if I run it, this is something that takes, this is the
the syntax of the application. So let's try to get the sagittal series for these data sets, which basically is running this tool. If I run this tool, it will go through all the different folders, all the subfolders, the subfolders, retrieve the file, go through all the DICOM tags, extract the DICOM. So it will take some time. And then when I run it, I realize that maybe I should have to wait longer than expected. So I will stop it and I will use our batch system, right? So all the computing intensive tools are on the batch system, not provided in the interactive environment. For this, we have one element that is called Jobman, which is basically a command line interface to a service that uses an extended object in Kubernetes that runs as a job, but has additional features that automatically mounts the data sets in the job. So in this way, whatever you see in your local environment will be available in the same folder in the batch job. So it facilitates a lot the development, right? So for this, Jobman requires a very simple set of parameters. Basically, you need which is the Docker image or the container image that you would like to use for running, and then all the, the application that you will run. So this is the list of applications or containers and the list of tags that we have. And then let's do the submission. For the submission, as you see, it's very simple. We simply relate Python 3 and the application that we want to run in a folder that is like the same folder that I have in my Jupyter environment, in my interactive environment. I also indicate the URL, the path of the data set, the orientation that I wanted to get a list, and then the output of the with the list, the output file in which the list of studies that fulfill this orientation will be stored. So I run it successfully, and then I can check if it is running, right? So as you see, Jobman has run the job, and it has been scheduled in one of our batch jobs. We have GPU batch jobs, we have big GPU batch jobs, small GPU batch jobs. We have different batch queues, sorry, for the execution on different types of jobs. Right. So since I already run one of the jobs before to be sure that we have, we don't wait so long. Let me just check you how to collect the output. So the output is very similar to, as many other places. I say logs and the identifier of the jobs, and then I can see the std out of the job that I have run. So trying to summarize, so in this environment, you can either process interactively with a limited amount of resources, but at least you can view and understand how the data is structured easily, and you can run batch jobs that will be scheduled on queues that have much more intensive computing capacity resources. Therefore, with this, let me just complete or conclude going to my last 2 slides. 1 second. I'll be happy to take questions after that, sorry. So the context, finally the context. So EUCAIM is aiming to be an authorized participant. It's aiming to be in the European health data space a provider of a secure processing environment which the data can be securely processed without having, without having to be transferred outside of the environment, with the advantages that it can deal with pseudonymized data if it is qualified as secure processing environment.
and will fit in the scenario in which other data holders can contribute. As a conclusion, so we are implementing this federated infrastructure. We try to maintain a high level of sovereignty for the data holder. I didn't check, but we can go back and check it immediately, that the data holders can track and see the usage of their data set. So we have a detailed monitoring of the different actions performed with the data set. So in this way, data holders can receive periodic reports on the usage of their data. We follow this federated model at different tier levels, and we try to be aligned with the European health data space. And with this, I will be happy to take questions. And maybe I will not unshare my screen by the moment.
Thank you so much. Thank you. Excellent, especially this work. We already have a question from Navian. Navian, I will enable probably Federico can enable Navian to talk, but we have his question in the Q&A box. Can you see it, or I can read it for you?
Naveen, you should be able to talk now.
Navian, can you try your microphone? Maybe you can talk.
Hi, can you hear me?
Yes,
we hear you.
Okay, great. Hi. Thank you for this wonderful presentation. Appreciate it. My question is, we work on various data sources when we are developing the model, and of course, the model will require a lot of data. Now, is it possible, any option to download this data with the relevant confidentiality signing and all, or that is just a no-no?
Well, it depends. I mean, in this way, we are acting as brokers in some sense, and also as processors of the data that is available there. It will depend on the conditions in which the data holder has released the data, right? So we are offering this possibility for those data holders that can sign this thing. However, I mean, considering what we are facing in the scenario of the European health data space, it will be likely that the downloading of data will be restricted with respect to the transferring to secure processing environment. That's at least the scenario that they are the Commission is thinking, right? So it will be good also to understand if those pipelines can be automated within this type of platform. I'm not meaning my platform, right? So SPs will be available all over Europe, right? And try to see if we can facilitate a maximum understanding which are your requirements.
Yeah, sure. We can have a detailed discussion, but as I'm sure you will appreciate that the data sources, if we are processing millions of data, then the speed of network is quite important to reach.
Absolutely. Yeah. That's an important point, right? Exactly.
Thank you.
I see Ahmad raised his hand. And another question from Marco.
Yes. Thanks so much for this talk. So my name is Ahmad. I am from SURF, the Dutch NREN. We are also dealing a lot with these kind of issues. We have our own SPE type of environment and a broker service similar to what you've shown. And so I have a couple of questions. I will just start with the main one, which I have, which is you showed this access request procedure in which you fill out the form, and then this request is then forwarded to the actual data owner or holder. And since there are many providers that are connected to this federation, right? Is this form in any way representing a common input required from these different data providers, or is this something that you came up with knowing that this is the minimum amount of information needed for such a request? And I'm asking this question because from my own experience, the conditions on access usually vary per provider. Some providers might not even want people to see the data, as you are currently showing this particular demo, right? You can see the images. Of course, for image specific use cases, that is a no-brainer to have that, but in some cases that is also a condition. Just to point out, there are various conditions, conditions on data access, and how do you see that generalizing in your case, or do you see that most of these providers have the same conditions? Because that was one of my questions.
That's a very, very important question, Ahmad. Absolutely. The point is that the data set is coherent subset of data with respect to the permissions, but you can define individual subsets. I mean, I know a case that is very close to you, which is the EUCAIM image. EUCAIM image has decided to have the data set split by provider. So you have you have all of them homogenized within with respect to the specific data model, but you have 1, 2, 3, 4 that correspond to different providers, and then there may be in the different conditions, and some of the conditions will not be couldn't apply to a request, right? So what I will suggest is that you fraction the data sets in a way that you can grant permission fully, and we can define individual permissions per data set. I mean, because this form can be customized per data set, and in the signing conditions can also be different. However, we try to help the researchers trying to minimize the number of documents that they have to sign, and try to convince everybody to align on the same conditions.
Are you making any efforts in standardizing these kind of individual conditions in a way that, you know, maybe they might not have to read a document, but they can see a quick overview of these conditions apply, these are conflicting, these are not, and is there any effort going there?
Not really, but we are trying to also, follow closely the work in data permit that is being defined at the HDS, because I think that they are also working on this point, right?
Yeah. Thanks.
Welcome, Ahmad. Maybe we can take Marco, that was before, and then Nathan again. Can you talk, Marco?
Yes, now I can.
Yes.
Thank you for the presentation, and sorry because I was distracted for a moment, so I don't know if you already explained it, but I didn't get why the user cannot download the data, and then how you can prevent that the user transform the data in a way that its output, from its output, it can restore the original data.
Yeah. Yes. The first, the measures that we put to limit the access to the data, right? So we only provide access through this remote desktop system, in which all the outbound connectivities, all the connectivities to outside are limited to a very restricted number of sites. In particular, one Python package repository, and other that is controlled by us. So the user cannot access outside. I mean, there's no outside connectivity, and because we are using plugins for the overlay network in Kubernetes that have very high level of fine-grained tuning of the policies, right? So these are the technical means, right? You cannot even copy and paste outside of the platform, right? So that's another thing that we limit to that. Of course, that you can take a photo. Of course, that you can create a fake model that embeds the data, or a generative, right? How do we prevent this, right? So for the experience that we have had so far, so we have opened this in a previous experience with an open challenge, in which we have 20 people creating models. And we had one person expert on models checking them and verifying if it looks like a model. But what we ask everybody is to sign a document in which they commit that whatever they produce is a model, and they are not extracting data. Of course, there are technical means that you cannot
put. I mean, you cannot have a full guarantee, but at least you have a legal document that bounds them not to re-identify patients and not to extract data outside of the platform. That's a complex scenario, of course. And I have to say that there's an intense debate in the HDS about the models created in the SPEs. Really, there's no clear decision yet, and we hope that they will not go to a very restrictive model, and they will go a permissive model in which you simply have to sign for that.
Okay, thank you. Very clear enough.
Thank you. I see Navam, please.
Yeah. So sorry for that. That's a quick one. I was trying to download this data prior to this presentation, and somehow I got a feeling that ORCID is mandatory. Now, that may be wrong. I will retry the process, but could you please confirm that's the Open Research and Contributor ID? Is that mandatory to get this data?
Sorry, I didn't understand your question.
I was trying to access the data prior to this presentation using your website, and somehow I got the feeling that Open Research and Contributor ID is mandatory. I think I read one of your programs.
No. Now I get it. Sorry. No, I mean, when you go very quickly, that's easy to solve. If I go to the dashboard, right, and I go here and maybe it will remember me. That's it. No, sorry, I have to. No, it remembers me. No, I mean, we support all the IDs that are available in the LSAAI, right? So maybe I can open another window. I can go to dashboard and try to explain. When I go here, it will come up in the LSAAI exactly, and I can select whatever there. So I can go to sign another. Click on the wrong button, and I can search for any IDP that is on the EduGain Federation. I have ORCID, and I can create my own account in LSAAI, right? But I can, for example, I don't know, if I go to CERN, do you have the IDP of CERN or SURF, right? So all of them are there, right? Oops. Oh no, SURF not.
Yeah, understood. So we are a private organization, so I don't have option 1 because I don't know where we have to register that. Option 2 is ORC ID, which I don't. So I created a life science ID, I think, but somehow it was taking back to ORCID. I will try again and see.
Okay, Ahmad, yes.
Yes, thanks again. I forgot to mention my compliments, by the way, for the very nice integration of all these parts. So this, for me, it's also the first one that I've seen it so well implemented and complete. So I'm very impressed. I forgot to mention it before. I have this question for a data provider to make their data available through this platform or through this federation. What is required from them to do? And is it possible to also connect external data repository systems? Like, for example, in the medical imaging world, you have this XNAT kind of repository system with all these medical images as well. I've had this question from one of the Elixir nodes asking SURF for this particular question, and I know there is ways with APIs to connect them to these SPEs. That's what we are trying to go with. I don't know if you've considered this. So with twofold question, basically in general, data providers in general, how do they connect, and external repository software systems, do they integrate?
Okay, yeah, thanks. Many thanks for the compliment. So with respect to the general data providers, we are trying to generalize this at the maximum. At this moment, we use as a backend Ceph system, right, for the storage, and we use a DICOM web client for ingesting the data. We are also going to other alternatives that can
I mean, have a backend different providers. With respect to the XNAT, in UCAIM, we have two reference nodes. This is my reference node, and there's another reference node that is deployed at the Erasmus Medical Center that uses directly XNAT. And we are thinking on this interoperability, but this is something that not fully covered at this moment. We can also provide with this. I mean, you can upload data, right? But it depends on the amount of information. And this data is stored in your private area, so it's not shared with the rest. Right? And this is another possibility.
Yeah.
If the data that you want to ingest is limited in size, it's tens of gigabytes or hundreds of gigabytes maximum.
Right. If you're ever gonna explore this integration more like systematically, please let's get in touch, because I think it's a common challenge also for SURF. And indeed, I understand the manual upload is always an option, but I know in XNAT people have defined projects already and have invited people in projects, so they want to like map that into these SPEs seamlessly. So yeah. Great. And one more technical question I wrote in the chat, maybe you can answer this, is about the performance, right? You mentioned you make these symlinks, and that's how you map the user access and the authorization on the data. So there's some local central storage, I assume, where everything is stored and then you read from there. So I'm imagining at some point, if the I/O gets too high, you might run into issues. If the application requires a lot of from the
Absolutely. I can tell you that we have been making tests. We made tests with the previous deployment that we had, and up to 24 simultaneous users. I mean, not fully reading the 24 of them at the same time. We managed to reach. Sorry, I don't have the numbers by heart. But now we have a system with NV links, disk, and much more faster network. So our dimensions were on the order of 25 concurrent users accessing intensively the data, but we will try to make a stress test in the future.
Yeah, which data center resources are you using actually for this?
Ours. No, this is totally local. It's at the Technical University of Valencia. We have a center, our own data center, and the Institute of Instrumentation for Molecular Imaging.
And you think this will scale, or you're looking into some kind of...
That's another interesting point. I mean, we have a very nice project started. EGI also participated, and CERN, I think also, if I recall correctly, which is called RIScale, in which we have one use case that will, demonstrate the temporary transfer of the data. Temporary. This is the condition that we realize that can be done in another environment with enough secure guarantees in which the data can be processed and then destroyed automatically. So yeah, indeed, this is something that we would like to explore once that we have gone through this process. Yeah.
Thank you very much.
Good point. Come. Sorry, I don't know who was next. If Marco was next, or now when it's an all hands, I don't know. Sorry.
No, yes, I have another question. Sorry, it's about this federated search. So, is there a central cached catalog, or every time a user run a query, it spawns a query for each data providers?
I cannot tell you in detail. Because this is implemented by the DKF set. This is also used by Elixir, if I recall correctly. Maybe I'm right for sure. Elixir, I'm not that sure, but maybe I'm right for sure. If I recall correctly, they are working on this caching system, right? We have not deployed this in our platform yet, but I can forward you to the people of DKF set that will know much better than me.
Thank you.
Naven, do you have your hand raised? Or it was an old hand?
No, that was earlier. Thank you very much.
Good.
Thank you so much. Thank you. It's excellent work. It's very, very impressive. Thank you for all your very nice demo. Went very well. And with this, we give very big thanks to Ignacio, and I hope to invite you back soon to give us an update of the new development. Also, thanks to all the participants today. Thank you for your discussion. Thanks for Federico work behind the scene to make everything smoothly. And we hope to see you soon in our future webinar. Thank you. Thank you very much.
Thank you very much, everybody.
Thank you very much. Appreciate it. Bye for now.